Please open in your learning workbook to page 174 as we solve some ALEKS problems involving this learning objective, graph exponential functions. Alright, here are two problems. Graph the functions f of x equals 4 to the x power and g of x equals 3/2 to the x power. The instructions say that we should use the following values for x: -2, -1, 0, 1, and 2, and that for each graph we should draw the asymptote. Okay, let's begin. So let's fill in the values -2, -1, 0, 1, and 2 in our table of x. And let's go ahead and plug in one at a time to find the values of y. We know that f of x is the same as y, so we have the equation y equals 4 to the x power. If x is equal to -2, then y is equal to 4 to the -2 power, which is the same thing as 1 over 4 to the +2 power, which is 1/16. So we get the fraction 1/16. If x equals -1, then y equals 4 to the -1, which is 1 over 4 to the +1, which is 1/4. If x equals 0, then y equals 4 to the 0 power. Any non-zero number raised to the 0 power is 1. If x equals 1, then y equals 4 to the first power, which is 4. If x equals 2, then y equals 4 to the second power. 4 times itself is 16. Okay, so there we go. We have our table of points. And notice the pattern here. As we move down the table, as the value of x increases, what's happening to y? It's being multiplied by 4 this time. 1 times 4 is 4. 4 times 4 is 16. And if we go up the table, we're dividing instead. 16 divided by 4 is 4. 4 divided by 4 is 1. 1 divided by 4 is 1/4. And 1/4 divided by 4 is 1/16. Okay, now let's create our graph. Our y values go all the way up to 16 this time. Once again, we only need quadrants 1 and 2. All right, here we go. There's 16. Half of 16 would be 8, and half of that would be 4. Half of 4 would be 2, and half of that would be 1. Half of 1 is a half, and half of that is a quarter. And 1/16 is pretty tiny. I'm not going to even try to draw that on my y scale. All right, so if this is where where y is 1 is located, then that tells me where x equals 1 would be located. So there's 1 and 2 and 3. And on the other side, -1 and -2 and -3. All right, so now I'm going to plot my points, and we're going to work from the bottom up. So let's start with 2/16. So 2 all the way up here at 16. All right, next is 1/4, 1/4. Next is 0, 1. Notice that our exponential function, just like all the others we've looked at so far, goes through the ordered pair 0, 1. -1, 1/4, so that would be approximately here. -2, 1/16. Now 1/16 is a positive number, but it's really, really small. So I'm just going to put a dot here that's just barely above the x-axis. And now I'm going to connect all the dots together. This is what exponential growth looks like. Okay, and since the instructions require it, we're going to draw the asymptote. The asymptote is the dashed line that the curve approaches but never reaches. The asymptote goes on top of the x-axis. Do not put the asymptote a little bit above or a little bit below, simply so it can be seen. If you're having trouble seeing an asymptote because it's sitting on top of the axis, just make it thicker, don't move it. All right, so there we go. This is our first example from Alex. We've got two Alex problems. We've done the first one, which is graphing f of x equals 4 to the x power.